And I like first to thank the people that is coming today for join us to discuss this important issue that is muddy bottom navigation through muddy bottoms. I especially would like to thank Han, that was who gave me the idea. I'm not sure if I have to hand him because then I have a lot of work to organize. But this is kind of opportunity meeting because this group is going to Montevideo next week. We have a Interco, which is the biannual meeting for cohesive sediments. It's going to happen in Montevideo from Monday to Friday. So, well, since from Europe, Rio de Janeiro is more or less passed by going to Montevideo, so not really. We take this opportunity to make this meeting, and well, we organize a bit at the last, not so, with so much time. So I'm sorry if we couldn't really reach everybody. Yeah, we try to advertise, but okay. I hope we have other opportunities to discuss this issue. We are always willing to work on mud. So what I'm going to do, well, we have you have the program there. I will give an introductory presentation, and we have quite some time for every speaker. So I hope we can have a lot of questions and we have time to discuss every issue. So that is main idea of this meeting is to discuss, to bring new ideas, questions, and well, I can see here people from the practical side of the issue that have to go through the math, and well, academics and ports authorities, etc. So that is the main idea of this meeting. Very informal, so feel at home, and well, raise your hand if you don't understand something or if you have any question. So I will talk a bit about the mobility of the bottom, yeah, and the consequent difficulty to address its position. So we are talking about depth for navigation, and we have the hydrographic surveys that the Navy conduct in order to build the nautical chart, but the bottom of the estuaries and sea, also rivers, is not fixed on time, and so I like to address this point a bit at the beginning. Then I will try to convince you that mud is good, can be good, that it is good. Then we will see a bit what is the bottom and try to introduce the next speakers in this morning, this day, during the day. Well, actually, mud is very good. And then just a short notice about the controllability and maneuverability. So the muddy bottoms, fundo lamoso. I hope our guests they will learn a bit of Portuguese today. At least how do we call mud? So the cohesive sediments that mainly the clay fraction is able to flocculate the fine fraction in a structure like you can see in the picture above. So this very a lot of water contained between the particles that go to the bottom, and then they form an open matrix at the bottom, yeah, with a lot of water inside. So it makes a diffuse transition between the water and the bed. There are formed lutoclines. Lutoclines are density gradients of sediments. So this is a very particular issue for the cohesive sediments. These steps in the suspended sediment concentration will form along the water column, but especially we have the one next to the column that we call normally primary lutocline. And the concentration that starts is about 10 grams per liter. So 10 grams of sediments per liter of water. So it's very dilute suspension, as you may see, and then grows up to, well, gradually up to high concentrations. These Lutok lines, to remain on time, need to be steered and needs to be hydrodynamic agents to keep them fluid, to keep them like they are. So we say, well, fofo, fluffy suspensions. So this is what we observe. And these hydrodynamic agents can vary from environment to environment. So here we have examples of Puerto of Rio Grande, where the storm surge or mare meteorologica is very important in this area. So here is the Rio Grande port, and here we have the lagoon, Dos Patos Lagoon, that is a high provider of fine sediments for the port. Also, it's important here the waves, because they're steered sediments all the time along the lagoon, so the sediments remain fluid and can be carried. And the Dinâmica that is in this area that is mainly controlled by the meteorological effect of the rising and lowering of the seawater. Port of Itajaí is another picture. The port of Itajaí is somewhere here, but this Itajaí river have a very dynamic river discharge, and then we have more control from the river and tides as well on the sediment that goes to the port of Itajaí. And this is our major subject lately, that is the Amazon mouth. And here tides play a very more important role, let's say, than anything else. So all these agents, they keep the sediments fluid. They prevent from the consolidation, but also they move the sediments from one place to the other. So we really need to know how these things work in every case, so in order to start thinking about how to deal with it. So here you will see a sediment concentration profile. This case is logarithm scale. Yeah, these are measurements along the tide. You see every line here is one moment along the tide. Yeah, and in the logarithm scale you can see what is in the suspension. But if we plot in no logarithm scale, what we will see is just one line here, and then this Lutok line next to the bottom. But it's basically what we call the bottom. Yeah? So the top of this primary Lutok line. Well, another example here, it is these are measurements in the port of Santos. So here are three points in the area where we have plenty of mud in the port of Santos, and here measurements with density along the tidal cycle in different points. So you can see that now we are in a no logarithm scale, so you will see this lower layer going up and down with the tide. So what is the impact of this mobility of the mud layers? Well, these are I think this is along a year, bathymetric register from different time along 1 year. So what you see this is all sand, and the muddy area is inside the port of Santos. And so what you see when you have a sandy bottom, we see something that you expect. Okay, you maybe it was dredged here, and then slowly the sediment was accumulating, and you have these small bed forms, etc. But you have a pattern that you can understand and follow. Next to the bend here, you will have, well, the outer bend more deep, and the inner bend, etc., etc. You have something that you can follow. But that the bathymetries in this area are quite, I would say, a bit crazy. We cannot understand these patterns. So what we think is this, well, you're measuring a surface that goes up and down with the tide, so it depends. Your ecobathymeter is going to give you an answer depending on, up and down, depending on the tide. So we have this difficulty to have these surveys with the, let's say, traditional, or what is in the Norman 25. This is the International Hydrographic Organization that provide these norms to how to make the surveys. So in this Norman, you have class A or category A. Is it? You correct me if I'm saying wrong. That we have to have some accuracy when, for instance, you pass one with the ecobathymeter twice and third time, and then you cross the line and they have to match. So this is a problem because we are looking at a surface that is moving with time. Thank you. Okay. But this is, well, the mobility of the bed, I just include this picture because it's not really this issue of having a mobile bed is not only a problem with we have mud bottom. So we always have to think that the bed is really dynamic according to the hydrodynamics. So this is, of course, Amazon, where we have a really high dynamic. But we can find examples also in southeast part of Brazil. But also here we have sandbanks. Here there is a superposition of 3 bathymetric surveys, and these are the sandbanks. The low, I don't know if you can see, there are 3 layers here. This is one bank here, that move here after 2 years, and they move in the color. So these banks move like this. And we have this bank move about 150 meters during the survey. If you have a hydrographic survey of about 30 days, you will have your bottom moving about 150 meters during the survey. So we really need to think about how to address this kind of thing, also for the sandy bottom. Well, the time variability of the fluid mud layers, I would say that the top layer, this lutocline, is quite mobile. It is where the ecobathymeter of 210 or high frequency ecobathymeter will register. And we really need to know about these mud layers. I mean, the source of sediments and how they form, and the mobility of the dynamic of this mud deposit. I think we are going to have some talks with Joris, Bas, and Ernesto will talk about, will address a bit this point. But the question is, what about the mobility of the mud layers where the nautical depth conditions are reached? So we are going to talk about a nautical depth definition. And the question is, how mobile is this depth? This is one question that we really don't know, but well, probably is not as mobile as the top layer, as we can see here in this graph. So I think Professor Ashish will address a bit about what happened in the layers, in the layers of the bottom layers, and the properties of this when we go down from the top of the lutocline. So in this point, I think that mud can be good. I mean, mud can be less mobility that we can expect when we just look at the top of the lutocline. So if we can be able to determine the nautical depth several times, probably we end up with the conclusion that this depth, it is more or less stable for a particular environment. But this is, so mud can be good, can be even better than the sand bottoms, less mobile. Well, if we go to the Piank recommendations to make to make to establish a channel for navigation, we will find that, for instance, what is called the ship-related factors or the extra additional depth when we design the channel. For the soft bottom, for muddy bottoms, we need to consider no extra depth. Also, if we go to the risk analysis under return periods, we will see that for soft bottoms or for muddy bottoms, these return periods fall considerably. So we have a good material to navigate on top of. So I would say mud is good. Yeah, it is quite gentle for the you can make a mask like this, but it's also gentle for the ship if you reach the bottom by accident or so on. So where is the bottom? So we talk about the Lutok line, which is mainly defined, the top of the Lutok line defined when we use the Echo 210 kilohertz. So it changes in time. It changes in time and space, but it also means that I think that is the issue that has been raised not only in Brazil but also everywhere, is that it's very costly to dredge. We are dredging basically dirty water. We have all kinds of associated environmental impact issues, because mud is difficult to use. Beneficial use of sand is very easy to find, but not so easy to manage fine sand, cohesive Lama, mud. So because of this, the Piank already for some time start with this concept of nautical depth, and we can talk about passive and active definition of this nautical depth. The definition is easy. I'm not going to repeat here because it's going to be addressed along the day. But basically, we want to define another depth that is safe for navigation and can be lower than the top of Lutok line. Determination is not that easy, and there's many investigation going on to address the properties of these mud layers and the navigability of this layer. Well, this is old concept. So Rotterdam Port started in the decade of 70s with this concept. And well, Alex here, Diego there, and Caio, they will talk a bit about this, the properties of the mud and the field work for determine this depth. Okay, so as I said, Piank in several reports already define, describe, and encourage the port authorities to use the nautical depth definition. So here we have the first report in 83 already, and the last report in 2014 also emphasize the muddy bottoms as a special chapter and give orientation about how to deal with. So they recommend to define this nautical depth is specific for each place, density by now as a practical criteria, and always to look at the maneuverability. If this is also in the Piank report. The idea is to keep the sediments navigable. This in this chapter, and we have this passive and active nautical depth definition. The passive means we go there and we can find a nautical depth that attend the needs for navigation. So we don't need to do anything else. So it's natural nautical depth. Active nautical depth means we can do something, and we can engineer the mud in order to keep it navigable. So this is an example of conditioning the mud. This is the port of Endem. where this is the mud, how it looks in the hopper. Yeah. So what they do, they dredge the mud from the bottom, they steer in the dredge, and they put it back. So I would not say they are dredging, they are conditioning the material. They are just putting up, and they put back in the bottom. So in this way, they keep this mud navigable. And so they apply this from 2005. I think they still apply. So they used to dredge for millions of cubic meters per year, and now, well, they don't dredge anything. So so the material is not removed, which is much cheaper, and also with much less problem with the environment when you try to dispose, even if it is clean, try to dispose this material. Well, water injection dredging, I think David is here, not yet. But yeah, he's here, sorry. So he's going to tell us a bit about water injection dredging. This has been applied in Bahia de San Marcos for 20 years, I think, already, as a way to dredge, or to put away the mud layers that accumulate in the canals. Also, the port of Itajaí. This is the port of Itajaí, and the dredge has been working before. I'm not sure. I think they are not doing that dredging anymore. But I would say that this water injection dredging, it is called dredging, but also we can think that this device try to keep the sediments fluid. So what we do here is inject a lot of water at low pressure. So that means we are basically making the role of the tides, of the waves, of what the nature does with making this sediment well, in more effective way, of course, because it's putting a lot of energy inside. So if we don't have the nautical depth by nature, we can also think in these muddy bottoms to use some conditioning of this mud in order to keep it navigable without having to remove it, so without having to really to dredge the material. So in that sense, I think that my mud is really so good. Yeah. So we will have then the last talk of the day, that is Daniel. He will talk a bit about this issue. Well, controllability and maneuverability, which are in the definition of nautical depth. We need to keep the ship passing by these fluid mud layers in a safe conditions. So we are not going to address this point certainly, but one of the effects that we have when the ship pass stratify water body is the generation of these internal waves, and this is already observed in the fjords of so Norway, where the ship really stopped because of the generation of this internal wave. In that case, was salinity stratification, and that make an effect on the maneuverability and controllability of the ship. So one of these questions is if we have to navigate, it is better to navigate over the top of the layer of the sediment, on the top of the Lutok line, or through the mud. That is. So I think Han will address a bit this point. Yeah. Okay. And well, I think another issue for controllability and maneuverability is, I think there is a difference when we are thinking about a ship that enters the port, and like Port of Santo, where you have this muddy bottom inside the port, and so you are really aware of when the ship is slowing down, and so in restricted areas, this issue of controllability and maneuverability must be different than when we are in port open areas, like in access channel outside the port, which is typically Amazon case.